Hello and welcome to 7.1 Notes. Today the topic is the Pythagorean theorem and specifically applying the Pythagorean theorem. So, what is the Pythagorean theorem? Well, the Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And I think a little interesting bit of trivia is in regarding to the movie The Wizard of Oz. And you may remember that towards the end of the movie, when the wizard gives the scarecrow a diploma, or gives him a brain, or I think tries to give him a brain, but ends up giving him a diploma. And then the scarecrow tries to state the Pythagorean theorem, but he gets it all wrong. He actually makes a few mistakes, like 2 or 3 mistakes actually, when he tries to state the theorem. He says that it applies to an isosceles triangle when it really applies to a right triangle. He also says, I believe he also says it's the sum of the square roots, but it's not the square roots, it's the sum of the squares. And I think he also says it's the sum of the square roots of any two sides, but it's not any two sides. It has to be the sum of the squares of the lengths of the legs, and then that will equal the square of the length of the hypotenuse. So anyway, a little bit of interesting trivia there regarding The Wizard of Oz. You've probably heard of that already. I kind of think it's, I don't know if they made a mistake or not. It's something that movie buffs have been debating for years. But anyway, the Scarecrow's theorem might work in the land of Oz, but it definitely does not work in our Euclidean world. So moving right along, the important part is that the square of the length of the hypotenuse has to be outside all by itself. Okay, so this part here is the hypotenuse. Remember, the hypotenuse is the length that is opposite the right angle. It's the longest leg in a triangle. So the hypotenuse squared is equal to this leg squared plus this leg squared. Very important that you square them. It's not this plus this equals this. No, that would be wrong. It's this squared plus that squared equals the hypotenuse squared. So let's see how this would be applied. Okay, identify the unknown side as a leg or hypotenuse, then find the unknown side length of the right triangle, and write your answer in simplest radical form. So moving right along, you don't have to write this down because this is the same prompt. I just put the prompt on this next frame here. And we have these two problems. So you can copy down these two problems and we'll work on these. So the solution, the answer to number 1 is gotten through the use of this formula. The hypotenuse squared is equal to the leg squared plus the other leg squared. So that would be c squared is equal to a squared plus b squared, where c squared is your hypotenuse. So in this case, the hypotenuse is 5. So 5 squared is going to equal the length of one leg squared plus the other leg squared. Okay, which is what we have there, just plugging in values. And remember, this equation only works for a right triangle. So there has to be a right angle in it, in that triangle, in order for you to use the Pythagorean theorem. Okay, so working this out now, we get basically the rest is algebra, right? We have 25 is equal to x squared plus 9. Solving for x squared, we get x squared equals 16. Taking the square root of both sides, we get x is equal to plus or minus 4, correct? Because the square root of 16 is also negative 4, right? Negative 4 times negative 4 is 16. But we're concerned only with distances here, right? And distances are always use positive values. So we're just going to be concerned with the positive value. So the answer is x equals 4. So in this case, x is 4. It's a 3, 4, 5 triangle. Okay, so now we're going to do this problem again with problem 2 in a similar fashion. So we have the Pythagorean theorem, c squared equals a squared plus b squared, where again c has to be the hypotenuse. And we have x squared is equal to 4 squared plus 6 squared, because in this case the unknown value is the hypotenuse, right? So the x squared is going to be the one that's all by itself on one side of the equal sign. And so again, we have x squared is equal to 4 squared plus 6 squared. The rest is algebra. X squared is equal to 16 plus 36. You combine the two and get x squared is equal to 52. Take the square root of both sides and you get that x is equal to plus or minus root 52. But we want it in simplest radical form. So that would be plus or minus 2 root 13. But again, we're dealing with distances, so we're only concerned with the positive value, so the answer is 2 root 13. Okay? Moving right along, problem 3. The top of a ladder rests against a wall 23 feet above the ground. The base of the ladder is 6 feet away from the wall. What is the length of the ladder? So this is the same prompt, and here's my visual description or schematic of what's going on. This represents the building, and this represents the ground, and the ladder rests against the wall, and it's 23 feet above the ground. Okay, so that's the 23 feet above the ground. And the base of the ladder is 6 feet from the wall. And what is the length of the ladder? That's our question. And remember that the way the building meets the ground is at a right angle. So that's a right angle. So hey, we can use the Pythagorean theorem to solve this problem, to find out the length of the ladder, or x, the length of the ladder. Okay, so using the Pythagorean theorem, we have that x squared is equal to 6 squared plus 23 squared, right? This is the length of the ladder in this case is the hypotenuse. The hypotenuse squared is equal to this length, one leg squared, so 6 squared, plus this length, which is 23 squared. Okay, so that's the Pythagorean theorem and how it applies to the length of this ladder. And moving right along, we can just use some basic algebra here. 6 squared is 36 and 23 squared is 529. Add the two and you get x squared is equal to 565. Take the square root of both sides and you get x is about 23.77 feet. Okay, in this case I didn't keep it in radical form because I wanted the length of the ladder, and so I did it in feet and rounded to the nearest hundredths place. Okay, 23.77 feet. Okay, this next problem is kind of an interesting problem. It says find the area of the triangle. Okay, find the area of the triangle. So we have this triangle here, and it's clearly an isosceles triangle because we have that this is 18 feet and that's 18 feet. So it's an isosceles triangle. And by definition, the length of an altitude is the height of a triangle. In an isosceles triangle, the altitude to the base is also a perpendicular bisector. So the altitude divides the triangle into two right triangles. Okay, so this height or this altitude divides this one triangle into two right triangles. Okay, we have a right triangle here, and this is also a right angle. So two right triangles. Okay, so again, we're trying to find the area of the triangle, and the area of a triangle, you need to know the formula for the area of a triangle, and that is 1/2 base times height. We actually covered that last semester. Area of a triangle is 1/2 base times height, where area of a triangle is 1/2. 1/2 is 1/2. That never changes. It's a constant. The base is going to be this base right here, the 30 value, and the height is going to be that. That's the height. So the area of a triangle is 1/2 base times height. Like I said, we already went over that and derived the equation actually last semester. So let's plug in values that we know. Area is 1/2 30 times h. And that's my h, that's my height, but I don't know my height. So I don't know my height, and I don't know my area. So that's two unknowns and only one equation. That's impossible to solve. You cannot solve one equation with two unknowns. I need another equation to help me find out what this one is. Well, I can use the Pythagorean theorem to help me find that out. So we have this triangle here. Okay, I just recopied this. And what I want to show you with this triangle here, this one that I've recopied, is that this portion here is a right triangle, right? We already went over that. That's a right triangle. So we can use the Pythagorean theorem, which states that this squared, the hypotenuse squared, is equal to that squared plus this length squared. And that length is actually equal to 15 because it's half of 30, right? Because this is an isosceles triangle, and the altitude to the base is also a perpendicular bisector. So this is bisected. So if this is 30 total, this must be 15, and this must be 15 as well. Okay, I'll give you a moment. Let me erase these marks here. So what I'm basically saying is, to find the height, we're going to use the Pythagorean theorem, which again states that h squared plus 15 squared equals 18 squared. H squared plus this length, which is 15 squared, is equal to 18 squared. Okay, so it's kind of tricky, huh? We're really trying to find the area of the triangle. So we have to have this formula for the area of a triangle, but we also need this formula because we need to use the Pythagorean theorem in order to find out the height, which we need for this. Okay, kind of tricky. We're going to use two equations to solve this one problem. Okay, so moving right along, h squared plus 225 equals 324. So h squared equals 99. Take the square root of both sides, and you get that h is equal to 9.499. So now I know my height. It's 9.499. And remember what I always tell you, you can write this number down just like I did on this presentation, 9.9499. But don't change it in your calculator. In your calculator, it goes on 18, 21, 23 places behind the decimal point, depending on what brand of calculator you have. So it's actually even a little bit more accurate, right, in your calculator. So don't round until you get to the very, very end of your problem. Okay, so going back to the equation, area equals 1/2 base times height. But hey, now I know my height that I got through the Pythagorean theorem, right? So area equals 1/2 30 times my height, 9.499. And so there's my answer, that the area equals 149.25 square feet. Okay? And then one last concept here are these Pythagorean triples. A Pythagorean triple is a set of three positive integers that satisfies the equation c squared equals a squared plus b squared. And the ones that I really want you to be responsible for and memorize are these: a 3, 4, 5, a 5, 12, 13, an 8, 15, 17, and a 7, 24, 25. Okay, those come up quite a bit. These other ones are just multiples of the one that's in bold. So in other words, that's a 3, 4, 5. But if you multiply it by 2, for example, then you would get 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So these are just multiples. But the reason why I'm giving this to you is I want you to memorize, again, this: 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Okay, it's also on the bottom of page 435, so you can also get it that way if you need to. Okay, well, that's the end of the lecture. If you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay, bye-bye.